I'm Andreas from Dynapac Sweden, and I'm also the inventor of Dynapac's patented seismic technology. Today I will show to you how seismic for asphalt works. And to do so, I have this model here with me, and I also have a glass of water on the table to indicate how effectively we transfer the vibrations from the drum into the ground. If we start this model, we can start it in a conventional way, meaning a machine without the seismic system active. For such a machine, compaction is normally carried out at a fixed, quite high frequency. That also means a high centrifugal force. Many people tend to believe that this high centrifugal force, which arises from a fast spinning of the eccentric weights, is the best way to compact. However, I will show you that that is actually not true. Because if we now let seismic decide the optimum frequency, it will look something like this. And as you can see, despite that I reduced frequency, I reduced the centrifugal force, the vibrations are much more effectively transferred from the drum into the ground, which can be seen by the water in the glass here. What we also see is that the drum amplitude has automatically increased from the previous setting. To show you once again, keep an eye on the water, keep an eye on the drum amplitude when I go back to the non-seismic state. The fluctuations are lower and the drum amplitude is also lowered. Thanks to the possibility of automatically being able to find the optimum vibration frequency, the seismic asphalt roller has the possibility to much more effectively transfer the vibrations from the drum into the ground. On top of this, the seismic roller has the possibility to record the asphalt mat temperature as well. That is done via an infrared sensor, one in the front and one in the back of the machine. These sensors are used to control the compaction frequency settings dependent on the temperature of the mix. Let's say you enter a very hot mix with your machine, a mix that might easily escape sideways under the drum when you try to compact it. For such cases, seismic asphalt will increase the frequency slightly and thus lower the amplitude to avoid the mix from escaping underneath your drum. On the other hand, as the mix cools off, it becomes successively more sticky and more difficult to compact. It requires a higher compaction effort to get the proper density. Seismic will automatically detect this and adjust accordingly. So, to increase the compaction effort, seismic will reduce the frequency in this way. As you can see, automatically the amplitude has increased and will, so to speak, increase the compaction effort on the mix. In this way, you can make sure that seismic will adjust both to the optimum frequency and the mix temperature to get the best compaction result. Based on extensive in-house testing, numerous field trials, and customer testimonials, we are confident in what we claim. And with seismic asphalt, we claim a reduced fuel consumption, which in turn means a lower carbon footprint, increased operators' comfort and lower noise pollution, and last but not least, less wear and tear of your equipment. Does this seem interesting? Please reach out to your nearest sales representative.